All right, so we're at section 1.3, pre-calculus 30, and what we're going to be doing is we're going to be now combining all the transformations that we've been learning about in 1.1 and 1.2. So 1.1 was all about translations, right? Slides, left, right, up, down. Not changing shape, just sliding, just moving. 1.2 was about the stretches, right? The vertical stretch, horizontal stretches. And now we're going to be combining all those together. So I kind of like this picture here. Isn't this a pretty cool building right here? That is pretty creative, okay? It looks like someone has just like punched the side of this building. It looks like it was pretty much the same as this one, yet somebody just really, squished it up there and kind of mangled it, right? Pretty neat. So obviously, these sort of transformations can happen in, architecture and different things like that. So we're going to study sort of the nature of how you transform something, and we're going to put everything all together. Okay? So what we're going to do here, okay, is we're going to look at certain graphs, and we're going to apply more than one transformation, and we'll see how that works out. So what we've looked at is we've looked at the parameters h, right, which is the horizontal translation. We've looked at k, which is the vertical component. We've looked at a, which is also a vertical component, but in a stretch, right? And we've looked at, what's the other one? B. Okay, and that's the horizontal, and again, that's the stretch. All right, so, messed up that H. Anyway, so what we're going to do is I'm going to show you kind of what the equation, so y equals f of x. This is the mother function, right? This is the mother function, and we're going to now transform this mother function, and we're going to birth a new function. And so the parameters are going to look like this: y minus k equals a times, now whatever that function is going to be kind of written here, but f of b. Now, we haven't put b and h together yet inside these brackets, and this is very important. The b value is sort of a constant that is multiplied by the expression x minus h. And this is actually going to be quite important to you later. Okay, so you have to write it just like that. Now, it is true that this is also a friendly way to write this. So I want you to write this one down as well, where the k value is just added on this side. Of course, this is, function notation, right? This is y now as a function of x only, and you don't have any constants over here and stuff. So this is a very common way that we're going to be writing that as well. Okay, so these are pretty important. You have to know that this is the format here, and this one as well, for all of the transformations that we've talked about. All right? So, there are some hints. If we're going to take a function and we're going to transform it, and we have all of these parameters to fulfill, okay, there is some hints to sketching. So I'm just going to write that down now. Okay, so sketching a transformed function. And of course, you're saying to yourself, Mr. Maxwell, why do I need hints on how to sketch a transformed function? Because I have my calculator, and it's just going to do it all for me. Well, unfortunately, you are not going to have your calculator for all of this. You need to know how to do this. You need to understand how it works. Okay? So just like in anything, I mean, if you use a machine in your chosen career, all right, if you are a trained professional, you have a certain understanding of how that machine actually works, right? And so this is sort of the time in your life when you learn about how these machines work, okay? So if you're in pre-calculus, you're moving into calculus. A lot of that is very abstract, but it is the basis of a lot of math that goes on in industry and in sociology population growth and decay of different elements and things like that. So this kind of math is important, although you don't do a whole lot of calculations by hand. In the future you won't be doing a whole lot of calculations by hand, but you will benefit from having an understanding of how this all works. So yes, I will make you do this manually by hand. So the tips are this. We're going to do really one transformation at a time. Okay, one transformation at a time. And what we're going to do is we're going to take our mother function and we're going to, let's say it's a parabola or something like this. And what we're going to do is you're going to take the first parameter, you're going to apply that. And I'm going to tell you about the order in which you should do that. But you're going to make a sort of with pencil or something, you're going to sketch what the graph would look like after each transformation. And so at the end, right, you're going to have all these different graphs. That's stage 2, and then you're going to move this, stage 3. It's going to come down here, and then stage 4. It's going to move over here, and this one is going to be your final transformation. You're going to highlight this somehow. Okay, so that's the way it's going to work. We're going to sketch, and I want to see kind of the dotted, lightly penciled, whatever, each step. Okay, that's how you're going to do this without making any mistakes. Okay, and so then you're going to have your original in blue here, your final in red. That would be mine. So we're going to do one transformation at a time. The next little tip here, okay, is we're going to apply the stretches first. Okay, so that is going to be A and then B. And it doesn't really matter which one of those you do first, because those are both the stretches. But I would suggest, and again, if you look at this, what happened there? So there it is. If you look at this, and especially this form right here, look at A shows up first, then B shows up next. See that? So I just, it used to be in an old curriculum, an old textbook that we used or something like that. It used to be A, B, C, D. It was easy, right? Start at A, then do B, then do C, then do D. Well, now they've got H and K here, okay? It's being fancy nowadays. But you still start with A and B, okay? Do the stretches first. And then, obviously, apply the translations last. Apply the translations last. So you can kind of maybe see what I did here, and I kind of modeled this for you. I did this one I drew first, okay, right here, and this would be sort of the vertical stretch, okay? So what I did, just kind of loosely here in my mind, I stretched it up. Now it's not sitting on 0, I know, so all of this, it would actually be a stretch like this, okay? I'm really sorry. Sorry for wrecking your life here. But it would actually look like this. But I did the stretch first, okay? So stretch first, just write that, stretch. Actually, you know what? Just to make this easier, hey, if I'm wrong, I'll just change the question so I'm right. There you go. So the stretch first, got it? Get it? Now I'm going to do a horizontal. See, the next one was a horizontal stretch. So now I went from here, and I applied this horizontal stretch to get this next, the green dotted here. So I did A, then I did B. Okay? All right, so then, now, here, H and K, okay, again, it doesn't really matter which one you do next because they're both the same. I would suggest moving along. So if we do H, then next, okay, that H would have been, well, I did K first. But now we would go, from here, we would go over to there. So this is a stretch. This one was a translation. Okay? And then, then we go down. So if I'm following this example, then I'll just erase these dots. And then to do that in order, so this green one now goes over to here. Okay? And then finally, the last one, we go down to get our final one. Okay? So this is what we're going to be doing. We're going to be combining all of these in today's lesson. Okay, got it? Okay, as we look at this problem here now, okay, we are going to take our original function, y equals the square root of x, that's what this function is, and we are going to transform it into this function right here. So first of all, we're going to talk about what transformations are applied, and then we're going to actually apply those transformations and draw the resulting graph. This graph right here of this thing, okay? So let's just talk, first of all, are there any vertical stretches here? Any vertical stretches? So that would be, what letter are we looking for there? Vertical stretch. A. Yes. Is there an A value other than 1? Because if A is 1, there's no vertical stretch, right? Just 1 times. So the A value is 3. Does everyone see that? This is the A value. Okay? So there's going to be a vertical stretch. Now, let's not sketch it just yet. Let's just talk about this first. Is there going to be now a horizontal stretch? Is there going to be a horizontal stretch or compression, but any kind of horizontal changing of shape? Okay, I have x here originally under the root sign. So do I have any number attached to x underneath the root sign now? Yes, I do. Okay, so I have this 2. So b is 2. Okay, b is 2. So there is a horizontal. Is that going to be a stretch to get wider, or a compression to get more narrow? Yes, by a factor of 1 over 2, right? Now the next step here, what am I looking for next? Looking for a horizontal. Now, what is h? Careful. Okay, I maybe heard 1, 4, but I heard some 2s or -2 or something. And you guys are, yes, you're on the right track. Please remember that when we're looking for h now, we have to factor this under here. H is not -4 or 4. It's not, the 4 is not, that's not part of it. What we have to do is we have to factor the 2 out, bracket, x. This is going to be -2. That's 1. Okay, so we have to go back to, right up here. Remember, this is what I said, you got to be aware that we have this situation. The brackets have to be there, so that b is factored out of this number here as well. Okay, so just as long as you cut that, that was a bit of a tricky one. So yeah, so we have a vertical stretch, we have a horizontal compression by a factor of 1 over 2. We do have a horizontal translation, a slide, and it's going to be 2 units, not 4. It's going to be 2 units. Which way? To the right, because this is negative. Yeah. So we have a positive x, and again, when you factor this b out, you have to make sure this x is positive. It has to be positive. So if this was -2x here, or a -2x, you have to factor a -2 out to make this positive. Very, very important. So this is our h at 2 units to the right. And then our k value over here, it's moved vertically, it's translated vertically. How many units which way? 1 unit up. Oh, yeah, it's up. Yeah. Now listen, if this 1 was on the other side and it was y -1, that's up. But when it's on this side, it's the same sign. Plus does mean up on this side. Okay? I'm sorry about that. Tricked you there. Okay, yeah, so you gotta remember this is up. Awesome. So to the right here, and this is up here. Okay? And this is going to be a horizontal compression towards the middle, and this is going to be a vertical stretch. Okay, reaching up to the sky there. Okay, so let's do this one parameter at a time. And what we're going to do is we got some points here. That's really nice. And we're going to move these points. So I'm going to use green for the first one. Okay, so let's do times 3. Now, is it the y times 3 like this? Or is it the x times 3 going up like that? Which one is it? Yeah, well, it's actually the y values times 3. Yeah, we're going up in the y direction. The vertical stretch, remember vertical is up and down, that's the y. So we take these y values right here, see, take the y values, and we multiply all those by 3. We keep the same x value. Okay, so the first stretch here. I'm going to multiply this 1 by 3, and I'm going to go up to 3 right here. 2 times 3 is going to be 6. So bear with me here. Got to go off the grid here. 3 times 3, what? You guys freaking out? 3 times 3 is 9. So let's go up here, and I'm sorry, my grid is just not lining up. Well, boo-hoo. Okay? So that's our first transformation. And of course, 0 times 3 is just 0. So that's why we have the same point here. So this is what I want you to do. With a little dotted line, I want you to just connect the points. Because we know that all the points in between these important ones that we looked at, they're all going to fit as well, like this, right? So that, and let's just zoom out a bit, that is going to be the stretch there, correct? Got that? All right, now this might be, I'm just going to leave this zoomed in a bit so we can see more of the graph. Okay, are we good? That one's taken care of. Now, the 2. What does this 2 mean? Well, each x value has to be multiplied by 1/2. That's what this 2 does. So now we don't go back to the original one. We move the x values from our first stage of transformation. So I look at these ones, and let's do this in blue. Okay, 1/2 x. So take all these x values, which here was 9. This is 9, and I'm going to go back to about 4.5. Same y value, but this one goes back 4 to 4.5. This one was 4. This goes back to 2. This was 1. This goes to 1/2. The x value at 0, half of that is still 0. We have some unrest out in the hallway there. Okay, so in blue, here's my next one. Okay, roughly it's like this. You see how that is a horizontal squish of the green one? Yeah? Okay, good. We've got the first 2 knocked off here. Awesome. Now, we're going to go to H, which means we're going to move now this blue one that we just made 2 units to the right. So, each of these points now get moved. So this 0 now is going to get moved to number 2, let's do this in red, okay? So this is going to go over to 2, that point. This point right here is going to go over to 2. See that? This blue point up here, which was 1/2 plus 2 is 2.5. See that? X value of 1/2 here. Okay, from here, this was a 2, so add 2. That's going to go, right? It's going to go to 4. Wait, what's going on here? 2, yeah, 2. Okay, so this one's going to go to 4. This one's going to go to, that was 4.5, to 6.5. Alright, so this blue graph, okay, so again, apologize for my freehand, but the blue graph should be an exact mirror here of the red one. Just shift it over, see that? What's that? What was this blue one here? That was 4 divided by 2, that's 2, so 2 plus 2 should be back to 4. Is that the one you're talking about? Yeah. So from the green, I divided it by 2, and then now with this translation, I added 2. So it should go back to the same point. Well, it's different than the green one, because remember, this red one has been compressed compared to the green one. But it's the exact same shape as the blue one. Yeah. So now we're just going to finish this up. But you might want to make your graphs a bit bigger if they're getting really crowded. A bit bigger, okay? So finally, just this last one, plus 1. Let's do the plus 1 in black, okay? And you're going to take each point from the one you just did, and you're going to add 1 to it. Boom, up there. This one goes, boom, up there. This one, up 1. Whoops, up 1. Okay, and then this up 1. So your final graph, I'm going to make it a little bit thicker here. Okay, looks like this one. Sorry? Oh yeah, it's totally okay. It doesn't touch the x-axis. Absolutely, because we moved this graph over and up. So now this is the new starting point. You bet. Yeah. Okay. So that's the end of that one. All right. So here's your assignment for 1.3. This is part 1. Okay. This video was part 1. There is a part 2 coming up, and the part 2 is where we take a look at two functions, and we determine, like this right here. This is the one we're going to do in the next lesson. We take a look at this right here, and we say, okay, f of x is the original. How did we get g of x? What parameters a, b, h, and or k did we apply to get this? And so that's going to be in lesson 2.